Hold up, guys. I hope you've already done the practice mock preparation that I prepared for you last lesson. If you have not yet done that, stop right there, click that card up in the top right, and do that first. There is no point in you just watching me talk you through the answers. You need to do the practice for yourself first. Once you've done your best effort on that, come back here and we'll take it up. I'll take you through the mark scheme as well as explain a few of the little details that you might not have understood from the mark scheme, as well as extend this into other types of questions that you're likely to see on this year's mock. If you've already done the practice and you've got it ready there to check for yourself, let's get started. As I said in the previous videos, exams tend to start with the easier questions, so I shouldn't have to talk you through too much of this, but you should know how to factorize and expand brackets for question 3A. The common factor, the number that both of these terms could divide by, was 7. And then make sure that the terms you have inside the brackets have been factorized correctly. For question B, watch out for those negative signs, particularly when they're in front of a set of brackets, because that -2 there will affect all terms inside the bracket. Feel free to hit pause and correct your answer before you see mine. When we multiply this through, that c will become -2c, but that -4 multiplied by -2 becomes +8. And then, of course, we simplify that by grouping like terms. Notice that the mark scheme gives you one method mark, even if you don't have all 4 of these terms correct. I think that's to account for the fact that most people likely would have made an error with the signs here. So if you had 6c minus 15 minus 2c minus 8 instead of +8, you'll likely get that one method mark, but you won't get your answer mark. There is no follow through here. Next for question D, expand and simplify. Here's a mark scheme answer. I would have started with a times 2a, making my 2a squared, and then done a times -1, giving my -a, so slightly different order here. And then 5 times 2a gave me my +10a, and 5 times -1 gave me my -5. Of course, we need to simplify this, grouping like terms. My +10a minus my a gives me my 9a. Note my method marks. For any 3 correct terms, I get 1 method mark, but of course, you need to have all 4 of these terms correct in order to get the correct answer, and you get 1 mark for the answer. For question 3, this was our probability question. The probability that the bead is yellow or blue, given that the probability of a yellow bead is 0.08 and the probability of a blue bead is 0.25. These two outcomes are mutually exclusive. A bead cannot be yellow at the same time that it's blue. So the probability that it's one or the other, the OR rule, we add them. So the probability that it's yellow, remember this is union or blue, is simply adding the probability of yellow plus the probability of blue. So that gives me 0.33, and of course I get 1 method mark for showing that I'm adding them. If you added them correctly, there's no reason why you shouldn't have your answer mark, but you get 2 marks for that. For part II, the probability the bead is neither yellow nor pink. Again, using some set notation for this, I could say that that is not yellow, and at the same time it's not pink. But an easier way to work this out would be to simply say that it's not yellow or pink. So putting yellow or pink together and saying it's anything but those colors. And to work out something that it's not what's inside these brackets is simply 1 minus what is inside these brackets. So that's 1 minus, and this is the probability that it's either yellow or pink. Now I typed out this working for you so that you could fully understand why the mark scheme says this. It's 1 minus the probability that we choose a yellow and also minus the probability that we choose a pink. That's what it would look like if I simply expanded out these brackets. And my answer is 0.82. The mark scheme for this is a bit confusing. It says to give a follow through if your answer to part AI is between 0 and 1. Now our answer to part AI is 0.33, which is between 0 and 1. And I assume that's simply because they want to see that you understand that probabilities are always values between 0 and 1. Although I personally think that giving you a mark simply for giving a probability answer between 0 and 1 is incredibly generous. Nonetheless, for your answer, it should be 82 hundredths. So I've written this as a decimal, but they're giving their answer as a fraction here, and a follow through for some answer between 0 and 1 again. I assume that's, again, using the probabilities that you're given above. Maybe you use them as fractions, but you've used them incorrectly as fractions, and you didn't get the correct answer of 82 hundredths. For question C, estimating the number of brown beads a G records, estimation should be given as some fraction of the number of tries, and that fraction that you should use should be the probability of success. That's the probability of getting a brown bead. The probability of getting a brown bead is 20 over 100 because there are 20 brown beads in the 100 beads altogether. And we're multiplying that by 60 because that's the number of tries we're taking. We don't expect all of those beads to be brown, but we do expect this fraction of those beads to be brown. So that works out to be 12. Again, you get 1 method mark for showing that you've worked out some fraction of 60. It should be the correct fraction, 20 over 100, or equivalent, so 2 over 10 or 1 over 5, and then your answer mark is 12. They say accept 12 out of 60, but do not accept 12 over 60, because that would just be a fraction of a bead, and that's not correct. Question 7, I kind of explained in our previous video. Percent increase is simply some percent change. Is always calculated as the amount of change, the difference in the values, divided by the original value, multiplied by 100. So this is the fraction of change. Times that by 100 gives us a percentage. Now, in the mark scheme, they work this out separately in parts. The amount of change was 153 minus the 25, so 28 goes at the top of this fraction. And the original value was the 125 centimeters, so that's why they did 28 divided by 125. And then to turn this into a percentage, we had to multiply it by 100, so 22.4. So you got 1 method mark for working through either that the difference between the two values is 28, or working out that 153 divided by 125 gave us 1.224. That's 0.224 more than 100%. So that's making it a 22.4% increase. I prefer not to work this way, and I think the examiners would agree because they're showing the working this way. But that is another way of figuring out how much increase that was. Question B I mentioned in the previous video as well because it's often very difficult to read these questions. We're not looking for 85% of some known value. We have a value and we know that it's 85% of some unknown value. We know that 153, his age at 12 years old, is 85% of however tall he is at 20 years. So we could set up an equation for this. The known value is a given percentage of some unknown value. And to work that through, a percent of an amount is simply multiplying that amount by the percentage and dividing by 100. If I want to work out what this unknown value in blue is, I'll need to rearrange this equation. So I'll take my 100 across and I'll multiply it. And I take my percentage across and I divide by it. Now I know what some of you might be thinking. It'd be a lot easier to simply say if this is 85%, I'll add 15% to that, and that would make it 100%. But this is 85% of the blue unknown value. I can't add 15% of this value and try to figure out something I don't know, because it's really 15% of the unknown value that I need to find. I don't know if I'm explaining myself well, but let me just show you this. And if you try and work it out your way, you'll see that we'll get different answers. So substituting into this, my known value, the height that he is at 12 years old, is 153. So 153 divided by the percentage, which was 85%, times by 100, or you could write it this way. I'm not sure if any of you would want to work it out this way, but that's simply saying that 85% is 0.85. And to work out a percentage of an amount, you could say that I'm going to multiply by 0.85 rather than multiply by 85 and divide by 100. Regardless, either way you do it, you'll get the answer of 180. So that is 15% more, but 15% of 180 more than the 153, not 15% of the 153 more than 153. Give that a try if you want to just figure it out for yourself, but trust me, reverse percentages, we need to set it out this way. Next, we've got question 8, and you should recognize that this triangle has already been split into 2 other triangles, which is really helpful because of this right angle we've got here. Since this is a straight line and this is 90 degrees, this must also be 90 degrees, so you've got 2 right angle triangles here. So in part A, when we're working out the length of AD, you've got the other 2 lengths of the triangle. More importantly, the 15 is a hypotenuse length. So when you use Pythagoras rule, make sure that that 15 is on its own on one side of the equation. So you've got a squared plus b squared equals c squared. Some people say a squared equals b squared plus c squared. Doesn't really matter, so long as you remember that the hypotenuse is the one that's on its own on one side of the equation. So the 15 is where the c is. So this means we've got length AD squared plus length 10 centimeters squared equals length 15 centimeters squared. Working this through, this gives us AD squared is equal to 15 squared minus 10 squared, or 225 minus 100, or simply AD squared is 125. Don't forget to square root that. And they put this in quotations because you might not have worked out the correct 125, but you've done the working through and you've followed through with whatever value you've got. So AD should be equal to the square root of your answer from above, which is square root of 125, or if you used surds to simplify this, this is 25 times 5, and 25 is a square number, so that's the square root of 25 is 5 times the square root of 5. This works out to be 11.2. Remember, in the question they asked us for 3 significant figures, so obviously we're not going to leave our answer in surd form. Our answer is 11.2, or anything rounding to 11.2. Now that's very generous of them. The question says 3 significant figures, and yet they're giving you the answer, even if you'd said, for example, 11.21. For part B, calculate the size of angle BCD. Give your answer to 1 decimal place. Again, remember that this is a right angle triangle that we've got over here. And angle BCD, start at point B, go to C, and then go to D, is the angle that's trapped in that diagram that we just traced over there. So it's the angle at C. And from that angle, I look across and I see 10 centimeters. That's the opposite side. It's opposite the angle that I'm looking for. And right next to the C, I've got 12.5. That's the adjacent side. It's obviously not the hypotenuse side. The hypotenuse side is the one we don't know and we're not interested in because it's across from the 90 degree over here. So using SOHCAHTOA in this right angle triangle, we're given the adjacent side, 12.5, and the opposite side, 10. So in this weird word that we've got here, we've got the A and the O. So it's not so, that's with the O and the H. It's not ka, that's with the A and the H. We've got the TOA, O and the A. So using TOA, would say that tan of the angle, and sine, cosine, and tan, they're always of the angle that we're looking for, or the angle that we've got. Tan of angle C is equal to opposite over adjacent, opposite being 10, and adjacent being 12.5. Now this works out nicely. They gave us the opposite and the adjacent in this case. It could have been more difficult because they had us work out length AD in this question. If they had given us length AD and asked us to work out that length, we might have had a follow-through error. So it's probably why they gave it to us. But in future, they may not. So be thankful for this one. Coming back to our working over here, the tan of C is going to be equal to the opposite, which is 10, over the adjacent, which is 12.5. Working that through, that's 0.8. So tan of C is 0.8. Be careful, that's not your final answer. Remember, this is an angle, and it certainly looks bigger than 0.8 degrees. It's not accurately drawn, however, but it's not 0.8 degrees. We still need to do the tan inverse to find the angle. Whenever you're looking for an angle, remember you have to use the inverse of this trig function. So tan inverse of 0.8, or tan inverse of 10 over 12.5, for example, that works out to be 38.7. So we get 1 method mark for setting up our trig function correctly, 1 mark for remembering to do the tan inverse, and 1 mark for your answer. It says to accept this rounded or truncated to at least 3 significant figures. However, that's very generous. If you had just truncated that, that just means cutting off the extra digits. That would be 38.6. That's not correctly rounded. So let's not get into the habit of doing this the wrong way, even though they're sometimes generous about it. Next, question 13. Again, in the previous video, I pointed out that this question was easier than most cumulative frequency curve questions because I gave you the cumulative frequency curve. So to give you an extra challenge, I gave you the frequency table that they might have given you that you would need to complete, that is, work out the cumulative frequencies, to then be able to plot the points to make this cumulative frequency curve. So let's see if you were able to do that. So between 60 and 80, I said that the frequency was 6, so the cumulative frequency would have been 6 as well. However, between 80 and 100, the frequency was 42, so the cumulative frequency, cumulate means accumulate, to gather as we go along. We're going to add the 42 to the 6 that we had before. So 6 plus 42 is 48. Continuing along, accumulating frequencies as we go. 48 plus the 38 gives me 86. And then 86 plus the 14 gives me 100. All together, the total frequency is 100, and I accumulated frequencies as I went along. So that's to show that between 60 and 80, there were 6 people with these IQ scores, but between 60 and 145, there are 100 people altogether. I know the graph's already been drawn for us, but just to understand how it was drawn, how we would do this now is looking at the cumulative frequencies. We would plot each of these points at the end of their classes. So this frequency of 6 is not plotted at the 60, it's plotted at the 80. Assuming that between 60 and 80, there were 6 people with these IQs. We don't know where they fall in between this range, but by the time we get to 80, we will have had a full 6 frequencies, a full 6 people there. Now looking at my graph here, it might be a good idea to show working for that. So for both my horizontal and vertical scales, I noticed that they were always jumping by 20. Every 10 squares was worth 20. As you can see from here, I've gone from 0 to 20 in 10 squares. And every 10 squares is worth 20. As you can see from here to here, 60 to 80, that's a jump of 20 in 10 squares as well. 10 squares is worth 20, 1 square is worth 2, and then I can follow those scales to see where I'm plotting my points. I can see that 80, that's 1, 2, 3 squares up. That's a frequency of 3 times 2, 6. And then I look at the end of this class as well at 100. I can see where this point is here. It seems to be 1 point down from the middle of 40 and 60. So that's 1 point down from 50. 2 less than 50 should be 48, and that's 48. Next, at 120, we should have a frequency of 86. At 120, going up the scale, this is 80. That's 1, 2, 3 squares above 80. Each square is worth 2, so that would be 86. And finally, at the end of this class here, at 145, we should get up to a cumulative frequency of 100. Now, 145, remember, each square is worth 2, so that's 142, 144, and in between these two lines here should be 145. And right in between those two lines, I've got 100 cumulative frequency. So I've plotted my points, and then I need to draw this nice smooth curve in between them. Now that's generally quite difficult for people to do, but you just need to try and make sure that your curve is as smooth as possible. We want to try to make it as symmetrical as possible as well, and it needs to cross through the points. So take care to make sure that your curve does actually cross through the points that you've plotted. We should see this nice S shape here, because at the very beginning we had a frequency of 0, and that frequency is constantly growing until we get up to the top, which is our total frequency. We didn't ask any more people their IQ, so that's not going to continue growing. That's going to level off. So it's nice and horizontal at the bottom and horizontal at the top. So now all of this was actually done for you for this question. So let's get started now with part A. Use the cumulative frequency graph to find the estimate for the number of adults in the sample with an IQ between 85 and 115. Now take care not to confuse your IQ with your cumulative frequencies. My IQs are down here, and 85 is just 2.5 squares past 80, and 115 is just 2.5 squares down from 120, so about here. And I've traced that up to see where that falls on the curve, because this is my IQ, but I'm curious to see how many people, so the frequencies. What's the cumulative frequency here? And that is approximately 10. And what's the cumulative frequency here? That's approximately 80. So I would say that in between these two IQ values, there were 80 people with an IQ less than 115, and there's 10 people with an IQ of less than 85. So between these two values, there should be 70 people. 80 minus 10 is 70. Now, the mark scheme gives you a little bit more leniency here. You get one method mark for 2 cumulative frequency values obtained using the IQ values of 85 and 115, plus or minus half a square. So your curve wouldn't be perfect, remember, but since they gave us this curve, it should be fairly accurate. And our answer mark we get from any answer within the range of 69 up to 73, unless clearly obtained by incorrect working. So you might have an answer that's in between these, but you might have done some very weird calculating here, which is not what they're looking for. For question B, the upper quartile IQ value for adults in the sample. For this, you need to remember that a quartile should remind you of a quarter, and the upper quartile is the third quarter. The first quarter is a quarter of the way through the data. The second quarter is actually the median, the middle of the data. The third quartile is 3/4 of the way through the data. If you thought that the upper quartile was the fourth quarter, that would just be the last value, the highest value. So we're looking for 3/4 of the way through the data. And 3/4 of the way through the data, we're looking at 3/4 of the total frequency, which was 100. So 3/4 of 100 is a 75th value. Now be careful here, because very often people forget and get confused with the frequencies and the IQs, and they put their answer as 75. Now that just means that 75 people had IQ values below this value, but what is this value? That's what we're looking for. What's the IQ value of the 75th person? So looking at our cumulative frequency curve here, the 75th person is here. 75 would simply be 2.5 squares down from 80, because remember our scale is 1 square is worth 2. Now, drawing our line across to see what the IQ is for that person, it comes across to here, and chasing that down, that seems to be at about 110. So I'd say that 75th person has an IQ of 110. So that's my upper quartile value for IQ. Checking our mark scheme here, I get a method mark for using the cumulative frequency value of 75. That's 3/4 of the way through the cumulative frequency. Now you might have written 75, or you may have just marked it on the graph as I did here. To get our answer mark, they're accepting answers in the range of 108 up to 112. That's just 2 below and 2 above our answer. And keep in mind our scale, that's just 1 square below or 1 square above. And again, they give you that mark unless you clearly obtained your answer with some incorrect working. So you didn't use the graph at all, you've done something completely strange and bizarre. On to question 16. This is another probability question. This is the second probability question on the same exam. So although I'd like to say that they don't like to repeat questions, there are different types of probability questions that they can combine on the same exam. Funny enough, this is combined events without replacement. Now that without replacement is really important. So Hema has 9 counters. Each of them have a number on it. Hema puts the 9 counters in a bag, and she takes a random counter from the bag and does not replace the counter. She doesn't put it back in the bag, so that when she goes in the next time and takes a second counter of the bag, there are no longer 9 counters to choose from. There now is only 8 counters to choose from. That makes this quite different from the previous example that we did. Work out the probability that the number on each counter is even. So that's the probability that she took an even number, and then the second time she went into the bag with a different number of counters to choose from and fewer even numbered counters as well, because she's already taken one out, she takes another even. Now you should remember the AND rule for independent events. Although she's taken out one of the counters, and that does affect how many counters are left in the bag, that doesn't affect her chances of taking an even as compared to an odd on her second try. So these are independent events. So the probability that one happens and then the other happens, we multiply them together. So again, since this is without replacement, the probability that she got an even on the first try is not the probability that she got an even on the second try. On the first try, the number of even numbers are 1, 2, 3, 4. So she's got a chance of 4 out of 9. Whereas on the second try, one of those even numbers is gone. So she's got 3 even numbers left out of 8. So our combined probability would be 4 over 9 times 3 over 8. Which is 12 over 72, which of course simplifies to be 1/6. And then from our mark scheme, we'll get one method mark from showing our correct probabilities being multiplied together, and an answer mark for either 1/6 or equivalent, as I had 12 over 72. Very often for these probability questions, they accept your answer as a fraction, even though your fraction's not simplified. But still, it's always a good idea to simplify your answer. I prefer to leave it as a fraction, however, rather than writing it as a decimal, because as you can see, as a decimal, this would be 0.16 recurring. And then of course there's the question, do I round this? Do I write this as 0.16 with a dot on top of it, or just do I truncate it and write 0.16? It seems they would allow that, but again, avoid that mess and just leave it as a fraction. On to question B, which required a bit more thinking here. Work out the probability that the number on the first counter added to the number on the second counter gives an odd number. Now, in order to get an odd number from an addition, you can't possibly be adding two even numbers because that would be even. Even if you added two odd numbers like 1 and 3, for example, that gives you an even number. The only way you're going to get an odd number from an addition is if you add an odd number with an even number, or you add an even number with an odd number. So that's what we're going to work out. What's the probability that we either do an odd number and an even number, or we do an even number and an odd number? And you should include both orders of that possibility. So the probability that we do one combination or the other, these are mutually exclusive events, so we add their probabilities. So we'll do the probability that we get an odd number on the first try. That's 1, 2, 3, 4, 5 out of 9. And then we get an even number. Now, keep in mind, we've already taken out one of the odd numbers. We still have 4 even numbers. So even though the total number of counters are different, the number of even numbers remains 4. So I've got 5 over 9 times 4 over 8. And then in the other order, the probability of getting an even number first, well, there are 1, 2, 3, 4 even numbers out of 9. If I took out an even number, I would still have all 5 of the odd numbers left. So the probability of an odd number after that is 5 over 8. Now you might say that these two probabilities are the same, 5 over 9 times 4 over 8, 4 over 9 times 5 over 8, but we do need to include both orders, both possibilities. So working that through, that gives me 20 over 72 plus 20 over 72. Of course, you could simplify that, so or equivalent, but that works through for us to be 5 over 9. Okay, so we get 2 method marks for that. One method mark for doing 4 over 9 times 5 over 8 or 5 over 9 times 4 over 8. And the second method mark would be for adding that together, having that 2 times. Then we get our answer mark for obviously working that through. So 5 over 9 or equivalent, 40 over 72 or 20 over 36. You can allow for that as a decimal again, but then there's this confusion. Do we give it as 0.5 recurring? Do we give it as 0.55? Do we put it as 0.56? So do we round or do we truncate? It's just a lot easier to leave it as a fraction. Now, as I warned you in the previous video, this question may be challenging, but you also have to prepare for similar questions like this, but in an algebraic format. So the example I gave you in the previous video, a set of n counters, that's not 9 counters, not 10 counters, I don't know how many counters. N counters are each numbered with a different value from the set of values where x has some value between 1 and n, and x is a natural number, that is, it's a whole number that's greater than 0, and n is an even number. So it's an even number of counters. This is an odd number of counters. Maybe it would be 8, maybe it would be 10, but we don't know. Work out the value of n if the probability of randomly taking 2 even counters from the bag without replacements is 5 over 22. So they gave us the answer of choosing an even and then another even without replacement. Now, go ahead and have a think through that, but I'm not going to talk you through that one just yet. If you want to go through questions like this, please check out this video down below in the description box, probability and algebraic questions, or SpongeBob solves algebraic probability. Our next question, question 17, was a proportionality question. It was worded quite nicely for us. P is directly proportional to Q cubed. But watch out because very often they word it like this. P is directly proportional to the cube of Q. And a lot of people don't read the words. They just see P and Q and say, P is equal to something times Q. Read it carefully. If a variable is proportional to some other variable or expression, it's some multiple of that variable or expression. So in this case, we would say that P is equal to something times Q cubed, not P is equal to something times Q. Now, we write this generally as P equals K times Q cubed because K is the letter we use for the constant of proportionality. Don't ask me why we use K, we just use K. Okay, now that we've got an equation, we'll substitute our values for P and Q into it. We're told that P is equal to 270 when Q is equal to 7.5. So if we've got those two values, we can work it through to figure out what K is. K works out to be 270 divided by 7.5 cubed, or simply 16 over 25, which gives me now a formula. The formula for P is that P is equal to this fraction multiplied by Q cubed. P is equal to 16 over 25 times Q cubed. Now to get full marks for this, we should have started with some kind of an expression or equation that shows that p is some multiple of q cubed. Generally, we write it in this format, but you could write that q cubed is some multiple of p. Do not just write that p is equal to q cubed because that is not true, and that won't allow us to find out what the value of k is. We need to find the constant of proportionality in order to write our formula. You get a second mark for correct substitution into a correct equation. So when we wrote this equation here, we substituted correctly that p is 270 and q is 7.5 and not the other way around. And we get our answer mark for working through that k was equal to 16 over 25 or 0.64 or equivalent. Next, for part B, we've already worked out our formula in part A that p is equal to 16 over 25 q cubed. We want to work out the positive value for q when p is equal to q. So this is a completely different equation from this one. However, we want to use them simultaneously together to find the correct value for q. So if we already have the equation p is equal to 16 over 25 q cubed, and we're told that we need to find out what q is when p is equal to q, let's make p equal to q. So instead of p equals 16 over 25 q cubed, let's write q is equal to 16 over 25 q cubed. I've just replaced the p with a q because we're told that p is equal to q. Now we've got an equation that's only got the variable q in it, and we can solve that equation to find out what q is. Now that might look a little bit confusing for you, but by laws of indices, we've got the same base here, q cubed divided by q. If there's no power there, it's a power of 1. And remember, when we're dividing two terms with the same base, we can subtract their indices. So we'll do 3 minus 1. So 25 over 16 is equal to q squared. We need to get q on its own. The opposite of squaring is square rooting. However, there are two possible answers when you square root. It could be positive or it could be negative, but we're looking for the positive value of q. So square root of 25 is 5, square root of 16 is 4. So the positive value for q is positive 5 over 4, or 1.25. Next, question 18 is about differentiation. Now, if you need a bit of a reminder about differentiation, differentiation is used to find the rate of change. And in the case of curves, differentiating the equation of the curve will give you the gradient function, which helps you to work out the gradient or the steepness or slope of the curve at any given point along the curve. So, for example, over here on the curve, you see the red line I've drawn? That's a tangent to the curve at some point, and it's clearly quite a steep positive gradient there. Here I've got another gradient, which is not such a steep negative gradient. And over here I've got another gradient, which is a positive gradient, but not as steep as our first one. So the gradient along different points of the curve are different, which is why the gradient function gives you a different gradient value depending on the x value you substitute into it. Steps to differentiating a y function in terms of x is you simply multiply each term in that expression by the power of the x variable and then subtract 1 from the power of that x variable. However, this is quite a simple example because it's already in the right format. We've got 4 different terms here, x cubed minus 4x squared plus 4x plus 3. Each term is separated from the other by either a plus or a minus sign, and each of these terms are some multiple of some power of x. Even this one, even though there's no x there, that's like x to the power of 0. However, you cannot differentiate any kind of equation if it's not given in the same simplified expanded form. For example, I could have given you the exact same equation, but in this format. X brackets x minus 2 squared plus 3. First, we would need to expand out that bracket to get clear separate terms, not x multiplied by a bracket, which is several terms which are sort of grouped together in that bracket. So expanding that out, I'll have x times 2 brackets here, x minus 2 and x minus 2 plus 3. Expanding that out, I get this quadratic inside those brackets. And expanding that out further, I then finally get this 4-term cubic expression. And it's the same as we've got above. If you need more lessons on differentiation, please check out the description box down below. It's quite a complex and complete topic, so you're going to need to get some practice in on that. But let's go ahead and differentiate this now. So first we'll take the power and we'll multiply it out front. So I've taken my 3, I multiplied it out front, so that's 3x, and then I took 1 away from that power, so it's x to the power of 2 now. Then I took the next power, the 2, I multiplied it out front, so 2 times the negative 4 made negative 8x, and I took 1 away from that power, so instead of x squared, it's just x. If I don't put a power there, it's because there's just a single x there. That's like a power of 1. For the next term, it's a little bit more confusing if you're new to this. When there's no power there, as I just said, that's a power of 1. So I've taken my 1, I multiplied it out front, so that becomes 4 times 1, still 4. X to the power of, now because that used to be a 1, I subtracted 1 from it, and it's going to become 0. But I wanted to show my working in here just to make sure you fully understand that. And then like I said with this last term here, this 3 doesn't have any x after it. That's like 3 times x to the power of 0, because as you should know, x to the power of 0 is the same thing as 1, so that's 3 times 1. So if this is 3 times x to the power of 0, I'll take the power of that x, which was a 0. I multiply it out front, so 0 times 3, x to the power of, and now that 0, I subtract 1 from it, becomes negative 1. But it really doesn't even matter what happens here, because I've just multiplied this full term through by 0. So this term is going to disappear. Any term without an x, when we differentiate it, disappears. So this becomes 3x squared minus 8x plus 4x to the power of 0, which means 1. So that's x is actually going to disappear as well, plus 0. So simplifying that, so that's simply 3x squared minus 8x plus 4 times 1, which is 3x squared minus 8x plus 4. So the actual differentiation of an equation is a fairly straightforward and simple part of this topic. But moving on to use differentiation in the gradient function, in part B, work out the coordinate of P. And you should notice that P is at a turning point on this curve. It's not sloping upwards, it's not sloping downwards, it's actually where the gradient is completely flat, completely horizontal. And that is the case at any turning point on a curve, at the local maximums and at the local minimums. The gradient will be equal to 0. Now, I can see that the gradient here is equal to 0 by drawing the tangent through point P. So I'm going to set my gradient function equal to 0, so dy dx equals 0, and figure out what I get for x. Now in part A, I worked out that dy dx was 3x squared minus 8x plus 4. So setting that equal to 0, I've got a quadratic here that I need to solve. Luckily, it's set equal to 0. I can solve this quadratic either by factorizing or by using the formula. Whether you decide to split the middle term and factorize this or use the formula, you're going to get 2 answers. You can see on my curve, I got one turning point up here, and I've got P, which is the turning point down here, my local maximum and my local minimum. I'm interested in the second value, not the smaller x value, but the bigger x value. So looking at my 2 values here, I'll get one value where x is equal to 2 over 3, and another value where x is equal to 2. I'm interested in when x is equal to 2. But we're not quite done just yet. In order to get our full method marks for that, we needed to use the correct factorizing, or if you use the formula, you needed to show substitution into the quadratic formula. So show this working. You could also get a follow-through mark if you didn't have the correct differentiated equation over here, but you had a 3-term quadratic that you somehow worked through to solve. And being lenient here, they've accepted if you just put a plus sign here rather than a plus or minus sign. Regardless, we are not done yet. We've just found out that x is equal to 2, but as you can see from our answer, we are looking for a coordinate, a 2, something coordinate. We're trying to find the y value when x is equal to 2. And to find that y value, you're not going to use the differentiated equation because that's just going to give you an answer of 0 if we put 2 in for x over here. But we have this original equation here, which is set out where y is equal to some calculation involving x. So if I substitute 2 into this equation, I get the value for y when x is equal to 2. So y is equal to 2 cubed minus 4 times 2 squared plus 4 times 2 plus 3. Working that through, that gives us 3. So our coordinate is 2, 3. For question C, the range of values for x for where the cube has a negative gradient. As I showed you before, the gradient all along this curve is always different. However, here it's sloping upwards, here it's sloping downwards, and here it's sloping upwards. That's pretty characteristic of a positive cubic curve. And this is a positive cubic curve because we've got a positive x cubed term. It starts low, it comes up, it levels off with a gradient of 0 there, dips down, levels off with a gradient of 0 here, and then dips up again. The negative gradient is between these 2 points here. where the curve seems to dip downwards. So that's between where x is equal to 2/3 and where x is equal to 2. So my range of values for x for where the curve has a negative gradient is between 2/3 and 2. I can show that using inequalities here, or I might have just written between 2/3 and 2. It says to accept as well 2/3 dash 2, but I don't really like that notation because that looks like a subtraction, or the words 2/3 up to 2. Do not penalize whether or not you've added that little line underneath the x, but typically we would not include the 2/3 or the 2 because that's where the gradient is actually equal to 0. Next, question 19 is sets and Venn diagrams. And I just wanted to point out as well, I think I mentioned it in the previous video, that this Venn diagram shows the actual elements in each set, whereas some Venn diagrams show just the number of elements in each set. So this Venn diagram here is equivalent to this Venn diagram over here, where you can see that in set A, there are 5 elements altogether, but 3 of them are out here, and 2 of them are here in the intersect of A and B. And then set B has got 4 elements in it altogether, but 2 of them are out here and 2 of them are, again, in the intersect. Don't forget as well that there are some elements which are not inside these sets, but we do need to include them. There are 3 elements outside of sets A and B. Now, we couldn't answer part A from this Venn diagram because here we don't see what the actual elements are, and question A asks us to write down the elements of A not. So all of the elements that are not in set A, which includes those elements that are in B because they're not in A. So that's 5, 6, 1, 7, and 4. For question B, this N out front means the number of elements that are not in the intersect of A and B. So I could use this Venn diagram to solve that as well, or I could simply count it from here. The intersect of A and B is this in the middle here, that's 2 elements, and there are 1, 2, 3, 4, 5, 6, 7, 8 elements outside of the intersect of A and B. Over here, I could also look at the intersect of A and B being here, and I could just say outside of that intersect, there's 3, plus the 2 here, plus the 3. That's also 8. For question C, again, we're asked to find the elements, not the number of elements. So like in part A, we want to list these numbers. These are the elements that are in the intersect of A and B, or they're not in the union of A and B. The intersect of A and B is this 8 and 9. And the union of A and B is everything that's in A or in B, including the intersect, so including the 8 and 9. But we want to list the elements that are not in the union of A and B, so not in this region here. That's the 1, the 7, and the 4. So the elements in the intersect or outside of the union of A and B includes all of those. That's 8, 9 because they're in the intersect, and 1, 7, 4 because they're outside the union. Part D requires a little bit more thought here. We want to write down the elements of set C, which is not drawn on here, but it's described. We're told that A intersects C has got the 0 with a line through it. That's a null set. That means that there is no intersection between sets A and C. So none of the elements that are in A are in set C. We're also told that B union C are the values 5, 6, 7, 8, and 9. And that's a big help here because I can see that inside set B, there's only 5, 6, 8, and 9. So 7 must be in set C. It must be because otherwise it wouldn't be in the union of B and C. And then finally, we're told that C has got 3 values in it. 3 values. It includes that 7. What other values could it include? It couldn't possibly include the values 1 and 4 because those are not in the union of B union C. They're not in this group of values here. Also, they could not include the 8 or the 9 because those would be in the intersect of A and C. So the 3 values that are in set C must be the 7, the 5, and the 6. On to functions now. Here we've got 2 functions defined which have a set of operations which we need to perform on whatever the input value is that we put into these functions, where x cannot be equal to 1. The reason x could not be equal to 1 is because of function g here. Mathematically, we cannot divide by 0, which is why they made this distinction here. We'll get a bit more into domain and range in a minute. For question A, we're asked to express the composite function gf in the form gf takes x and does something to it. Now, in this case, we're not just substituting some variable or some letter into the function. We're substituting a whole function into another function. We're taking the function f, which is this here, 2x squared plus 1, and we're substituting this full expression, or this full function, into function g, which is this function here. I prefer to write my notation like this. G of f of x is the same thing as g, where f of x is the input. So if I look at what function g is 2 times the input value over the input value minus 1. In the case of substituting f into the function g, this is 2 times function f of x over the function f of x minus 1. And of course, we've got the function f of x here. That's 2 times 2x squared plus 1 over f of x again is 2x squared plus 1 minus 1. So this gives us one of our method marks, but of course it's not simplified. We need to expand that bracket out and simplify this down. So the top expands out to be 4x squared plus 2, and the bottom, I can add 1 and then subtract 1, and that will just cancel itself out. So that's just 2x squared on the bottom. This fraction can be simplified. Remember, to simplify a fraction, we don't just cross things out. So I know some of you might have looked at the x squared, same thing, cross them out. That's not how we simplify fractions. We simplify them by dividing both the top and the bottom by the highest common factor. In this case, the highest common factor is 2, because all of the terms on the top could be divided by 2. I factored out the 2 to make that clear so that you could see if I divide both of those terms by 2, I'd have 2x squared plus 1. And the bottom, we can clearly see it's a single term. It divides by 2. If I divide that by 2, the x squared would be on its own. Now, this is where we're going to get our answer marks here. However, we could write this in a slightly different way. Looking at the two terms in the numerator, the 2x squared and the plus 1, and each of those could be written separately as their own fraction. 2x squared over x squared plus 1 over x squared. Now that's how they got this 2 here. 2x squared over x squared would simplify to be just 2, while 1 over x squared remains a fraction of 1 over x squared. So this could have been simplified a little bit further. However, we get the full marks for leaving it in this format. We only get the method mark, however, if we've left it in this format because it's not fully simplified. Part B talks about the inverse function, and I'm going to get into this a little bit further than I do in this question, and I suppose you could probably imagine why. As we're preparing for the mock, you're going to want to pay attention to this. Now, the inverse function of function g is simply reversing what function g does. So g takes the input value, multiplies it by 2, and then divides that full answer by the input value minus the 1. We want to undo that process, but it's a bit difficult to undo, to think about what's happening first, what's happening next. So the easiest way to do that is to simply say that function g of x is the same thing as y. Y is equal to 2x minus 1. Now, I want to find the inverse of function g of x. So rather than doing all of this to x, I want to undo it all to the y. So to find the inverse function, I'll just swap the x's with the y's, and I'll rearrange this equation to make y the subject. That way, although we'll have y equals something, this y is the inverse of function g, while that y is function g itself. So reversing this process, I've got a fraction here. The easiest way to get rid of a fraction in an equation is to take the denominator to the other side and multiply. So I've multiplied the x by the y minus 1, leaving me with 2y over here. And remember, I want to make y the subject, so I'll take both of my y terms over to the same side. Leaving this negative x over here, I've taken the xy, which was positive, over to this side, so I've subtracted it. And to get y on its own, I factored it out of both of these terms, and then I've left y completely on its own by taking that bracket to the other side. Y was being multiplied by 2 minus x, so now negative x is being divided by 2 minus x. So I've got my inverse function. Remember, this is not the same as the function g of x because in this step here, I reverse the x's and y's. If you don't like having negatives in your fraction, you could divide both top and bottom by -1 and leave that as x over x minus 2. I've changed the signs of all terms in that fraction. Now, although this question doesn't ask for it, let's get into the different input and output values of functions and their inverse functions to ensure that you're really going to be ready for this mock, as well as any other exam that might deal with functions. So as we said in the beginning of this question, x cannot be equal to 1, particularly for function g, because if we input a value of 1 into this function, we end up dividing by 1 minus 1, that's 0. And mathematically, it's not possible to divide by 0. This is going to have some implications on the possible input values as well as the possible output values of different functions. When you input a value from the domain of possible input values into a function, the resulting output value is a value from the possible range of output values. So the words domain refer to the possible input values and the word range refers to the possible output values of a function. The domain for any function, so the values we put into a function, becomes the range of its inverse function. So for this example, function g of x, 5 is a possible input value. So 5 is part of the domain of function g. While 1 is not a possible input value, 1 is not in the domain of g. We can't divide by 1 minus 1, we can't divide by 0. However, we can multiply 5 by 2 and divide by 5 minus 1, that's 4. That's simply 10 divided by 4, which is 2.5. 2.5 is an output value. It's a value in the range. If I substitute 1 into function g, as I said before, 2 times 1, no problem there, is 2. But divide that by 1 minus 1, I'm going to get a math error because we can't divide by 0. So without doing any more work, I know that if I substituted 2.5 into the inverse of function g, it would work backwards through this process and would give me 5 as the output value. Whereas in order to get 1 as an output from the inverse function, I would have to put an impossible value as the input into the inverse of function g. This brings me to the conclusion that the inverse function of function g may have 5 in its range. It's a possible output value for the inverse function, but 1 will not be in that range. So if 1 is not a possible input value to the function, then 1 is not a possible output value for the inverse of that function. Now, if this is the first time you thought about the implications of the inverse function on what your range or your domain might be, you may want to hit pause right now and have a think about that before we move on. For question 22, this is a cosine rule question. Now, of course, on the exam, they won't tell you it's a cosine rule question. You can look on the formula sheet and you do have both the sine rule and cosine rule formulas, and they work for any type of triangle. This is not a right angle triangle, so I won't be using Pythagoras and I won't be using SOHCAHTOA. But the way that we decide whether we're using the sine rule or the cosine rule is simply that the sine rule involves 2 side angle pairs. Now, so that I know the sine rule has 3 fractions set out here, but you only need 2 of those fractions in order to form an equation. And the cosine rule involves all 3 side lengths, whether you have them all or you have 2 of them and you're looking for one of them, and 1 angle. Maybe you have that angle, or maybe that's the one thing that you're missing that you're looking for. And that angle should be opposite the side of interest. Now, in this case, I've got all 3 sides, and I've got 1 angle. And the side that is opposite from that angle is what we call the side of interest. It's the side that's different from the rest because it's across from the angle, it gets set up in the formula in a different way. So in this question, we actually know all 3 sides and the angle. However, 2 of these sides are written algebraically, so we're going to use the formula to work out an equation which we can solve to find x. So substituting into that formula, I'm going to use this as a, and then it really doesn't matter whether I call this b or this one c. However, this triangle is nicely labeled for us where this is angle A, this is side A, this is angle B, this is side B, and this is angle C, this is side C. So let's set it up that way. Here I've substituted an a squared, which is this squared, is equal to b squared, which is this squared, plus c squared, which is this, squared, minus 2b c cosine of a. If you're good with your surds, you'll know that 2 root 7 squared, 2 squared is 4, and root 7 squared, the square root of something squared, just cancels out the square root signs. If I've got a bracket squared, I must write that bracket out 2 times. Do not just square the first term and square the last term, because you'll be missing the middle terms, where we do 2x times 1 and 1 times 2x. So I've done that for both of my brackets. This bracket's also being squared, so I've written it out twice. Cosine of 60 is a nice one. If you write that in your calculator, you'll see it's exactly 0.5. It's exactly a half. So in this next step, as we've multiplied things out and simplified them down a bit further, I've multiplied these 2 brackets together and simplified. I've multiplied those 2 brackets together and simplified. And I've got negative 2 times. Now this cancels out the negative 2x and the positive 2x. So I've just got 4x squared minus 1. And times that by a half. Multiplying by negative 2 and then multiplying by a half is going to simply be the same as multiplying by negative 1, which is where I got my negative 4x squared plus 1 here. Make sure you didn't make a positive negative error there. Negative 1 times negative 1 made it positive. So this actually simplifies all through to be 28 equals 4x squared because of this 4x squared plus 4x squared minus 4x squared. And then the plus 3 is simply adding together the 1, and the 1. And my x terms, the terms with just x in them, my 4x minus my 4x is canceled out, so it's just left me with these 2 terms. Of course, if I take the 3 across, 28 minus the 3 gives me just 25. And if I want to get the x on its own, I'll take the 4 across, I'll divide by it. I got x squared equals 25 over 4. To get the x on its own, I need to unsquare that, so square root it. The square root of 25 over the square root of 4. Remember, there's a positive and negative answer here, but x is a length and it couldn't be negative. So x is equal to 5 over 2, which is 2.5 or 2.5. And there we have it. We get method marks for substituting correctly into the formula. You may have substituted 2 root 7 into your calculator and got a decimal value. It's best to work with exact values, however, so keep working in surds so you get the right answer. It says here that we can condone putting 2 root 7 squared into the formula like this instead of using brackets. However, that's not perfectly correct because that would only square the square root of 7. That's going to give you problems, especially if you didn't square the 2 and you ended up with just 2 times 7 instead of 4 times 7. However, they are very generous and they gave you a mark if you put 2 root 7 squared. Our next method mark is simplifying this as much as possible. And then we get our answer mark for 2.5 or 2.5 as our answer. OE stands for or equivalent. But the dependent on at least one method mark means you're not going to get any mark for your answer if you didn't at least show that you substituted into the formula or showed some simplification of that formula. So don't try and substitute everything directly into your calculator. It's not going to help you get the marks. Show your working, please. And that brings us to the end of this video. I know this is a long one, so well done for you for sticking it through. I hope you found some really good value in this video. Until next time, good luck with the rest of your studies, good luck with your exams, and I hope to see you soon. Bye!